Welcome to myprojectbazaar.com. Our product title is a thermal energy harvesting power supply with an internal startup circuits for space making. Let us see about the abstract of our product. The very large scale integration is the process of creating an integrated circuit by combination of thousands of transistors in a single chip. The microprocessor is a VLSI device. Before the structure of VLSI technology and ICs had a limited set of functions they could perform. An electronic circuit might consist of a CPU, ROM, RAM and other devices and logic. VLSI lets IC designers out of all them into one chip. The proposed implementation is thermal energy yielding power supply. The designing process of the power supply does not need any battery for startup and is used to power up any device with a load of 50 kΩ. The power supply circuit includes an oscillator, charge pump, boost converter and a comparator. The circuit is designed to handle the maximum load of 50 kΩ. A minimum voltage of 40 mV is needed for the circuit to start up. A maximum power of 18.03 milliwatts can be obtained from the output of the boost converter circuit. This implementation is done in Tanner EDA tool in CMOS technology. In CMOS technology, the nanometer is a main thing. So changing the nanometer and also corresponding output will be changes. The power consumption is the main output. Next we see about the flow diagram of our process. In this flow diagram, the input is a thermal energy. That thermal energy is considered to fed into the charge pump. In the charge pump is further boost up the values from the multi-feedback oscillator. Using of multi-feedback oscillator that remove the oscillating signals from the input. Then the charge pump is charged the output of the multi-feedback oscillator. Then that is fed into the startup boost converter. In the startup boost converter, the charge pumped output will be boosted into further value. Then the startup boost converter is fed into the steady state boost converter through a 2:1 mux. And also the comparator is used to trigger the startup boost converter from the output of the startup boost converter and input of the startup boost converter. Then the 2:1 mux is compared output is given into the selection logic, and the output of the 2:1 mux is fed into the steady state boost converter, and finally the output will be get in the 50 kΩ resistance across. And also the output is fed into the comparator. So in the comparator is comparing the both input and output signal that generate the selection signal. This proposed design consists of ultra low voltage oscillators and charge pump boost converter and a hysteresis comparator. The ultra low voltage oscillator is used to generate the required clock base for the proper operation of the charge pump system. The charge pump circuit is used to increase the input voltage for the other circuit to operate successfully. The output voltage of charge pump is used as input to the boost converter circuit when the specific output voltage is not obtained on the boost converter. And also this process is done using of. Next we see about the running process of our product. In this proposed implementation is done in CMOS technology in the Tanner EDA tool. First of all, we open the Tanner EDA SEdit tool. In the SEdit tool, we create a new file. After then, we creating the cells. So from the cells, then we click the library and add the all library files. Then we assign the which kind of NM technology we used. For example, 40 NM or 20 NM. So that corresponding library file is included in the library. In opening the cell 0 and add a library setup libraries, then we click the corresponding values. So these the major initial parameters to include the SEdit tool. Then we click the run icon, then the output will be displayed. First the T-space window will be open. In the T-space window, the corresponding passing time, setup time, transient analysis time will be shown. These are the system timing. So this is the corresponding timing to take the overall output. And next one is the corresponding output waveforms. So this is the power waveform. If you want to measure the power waveform, the minimum and maximum value, you choose the horizontal axis, then the corresponding ty will be changes. So below one is the input and output waveform. So here the bottom value is the input data. The input data is oscillating signal. The topmost value is the voltage value. Here the input value is zero point 0.4 millivolt and the output is at 2 volt. So that is value is posted into 2 volt. And the next one is the output waveform of input and output. So the above one is the output waveform and below is the FFT analysis. So using of this process is done in for 500 hertz megahertz frequency ranging. So the power consumption also reduced and also the output will be reached 2 volt. Thank you for watching this video.